Greetings and welcome to the module 12 titled NMR Spectra Interpretation. The objective of the session is to learn the interpretation of NMR spectra, and the session's outcome, at the end of the session the learners will be able to interpret the NMR spectra. See, before going to this, let us revise the contents of the previous module. We all know that the number of peaks obtained in an NMR spectra is purely depends on the number of identical protons present in the molecule. The number of peaks purely depends on the number of protons, identical protons present in the molecule. In this context, let us discuss two NMR spectra of two different compounds. One is aliphatic, another one is aromatic. With that, you can understand how one can interpret the NMR spectra of organic compounds. In this spectra, that is NMR spectra of tertiary butyl alcohol, we know that we are having two types of identical protons, that is 9-methyl protons one type and 1-hydroxy proton another type. These two protons are having different chemical environment because hydroxy proton is connected to the oxygen, so oxygen is electronegative, which attracts the electronic clouds towards itself. That is electronic cloud of hydrogen towards itself. Thereby the hydroxy proton is de-shielded and it experiences high magnetic field. We know that the magnetic field is directly proportional to frequency, thereby it will going to have high frequency. Since this hydroxy peak is coming far away from the tetramethylsilane reference, so it is given as downfield, whereas the 9-methyl protons are shielded because the carbon are electropositive, which donates the electronic cloud to the hydrogen, thereby it is highly shielded, and shielded protons used to experience low magnetic field and thereby low frequency, and it is appearing very close to the tetramethylsilane, so it is upfield. Similarly, if you look upon this spectra, it is NMR spectra of benzyl alcohol, here you are having three different protons. First, aromatic protons, second, methylene, that is CH2, third is hydroxy. See, you can observe in these two spectra, the methylene of aromatic, that is benzyl alcohol, is coming far away from the TMS. The reason for this is, you know that in our previous module, factors affecting chemical shift, anisotropic effect, due to the anisotropic effect, the 6 hydrogens used to be de-shielded. On that basis, this CH2 is de-shielded, so we are getting around 4.6 ppm. Whereas this hydroxy is connected to the methylene, so it is coming around 144 Hz, that is 2.44 ppm. In this, there is 5 methyl protons are de-shielded, so it experiences high magnetic field, that in turn gives you high frequency. Since it is far away from TMS, it is downfield, and here this hydroxy is shielded when compared to CH2, and it experiences low magnetic field, and it gives a peak very close to TMS, hence it is upfield. In this way, one can interpret the NMR spectra. See, the NMR spectra comprises of peaks. That peaks gives the information about the type of identical protons present in the molecule, and the distance of the peak from TMS gives whether the protons are shielded or de-shielded. In short, I would like to tell you the peaks which is appearing very close to the TMS are shielded, and the peaks which is appearing far away from TMS, that is de-shielded, and number of peaks gives you the information of number of identical protons present in the molecule. These two information one can extract from the NMR spectra in a very lucid and easiest way. Thank you for your active participation. If you have any doubts, clarify in the discussion session. Thank you, one and all.